So, we meet again. Hello, guys. Thank you for joining me again for hopefully what is our last week of home learning. Fingers crossed, our last ever home learning, but who knows? If you haven't done so already, please complete your retrieval quiz for the lesson. The answers are based on the last lessons that we've covered. So, good luck. Pause the lesson video, complete your answers, and come back for green marking your own work. Okay, so the answers are: to test for carbon dioxide gas, we use lime water. Remember, it should go cloudy. If we are using a precipitation reaction to test for copper ions, we add sodium hydroxide solution to our sample. If the precipitate formed is blue, we know it's got copper ions in it. If we're using a flame test to test for copper ions, the flame should give a green colour. We can use spectroscopy as opposed to a flame test to identify the metal ions in a compound. Remember, spectroscopy is an instrumental method which is more accurate, and it also gives us quantifiable data. It can tell us the concentration of each metal ion. Number 5, if we're using blue litmus paper and it turns red and then white in gas, we know it's chlorine gas. Number 6, if it's made of only one type of atom, it must be an element. Water is a compound. Remember, it's made of H2O, two different types of atoms chemically joined, chemically bonded. Number What should be 8, it says 6, it should say 8. Number 8, what name is given to a mixture that has been designed to make a useful product, and that is a formulation. We use a pencil to draw the baseline in chromatography because it is insoluble. Remember, we don't want it dissolving and taking part in the experiment and giving us unreliable and inaccurate results. And finally, the challenge was quite difficult today. Describe how to test for the presence of sulfate ions. Well, to test for sulfate ions, we would add barium chloride solution to our sample. And if a white precipitate forms, we know it contains sulfate ions because that white precipitate, the solid formed, is barium sulfate, because the barium reacts with the sulfate ion and the chloride ion is left in solution. So today we are doing a summary of the topic, chemical analysis. I didn't want to start a new topic in our final week of home learning. It would be pointless. So we're going to summarize everything that we've learned in this topic. By summarizing a topic, it's helping you to gain a deeper understanding of the content that we've learned. The keywords, none of these keywords should be new. All of these keywords we have covered in previous lessons. So make sure that you are aware of them. There shouldn't be any that you don't understand. If there are, what I would suggest you do is pause the video and look them up in your revision guide or on Google or on the last lessons that have been uploaded on our Google Classroom. Be resourceful. Okay, so just a quick overview of the topic. We have covered all of these lessons now. We've also had a review. We've had 2 review lessons last week where you applied your learning to your Seneca tasks. And some of you got some really good pass rates on that, so that was very pleasing to see. So today is quite independent. You've got one big deliberate practice task, and that is to create a summary sheet for the chemical analysis topic. Now, you can use any format you wish. Now, you might choose to do a poster, you might choose to do a mind map, you might even choose to do a PowerPoint of the topic chemical analysis. However you choose to do it, whether that's on paper or on an electronic device, make sure you're uploading your work. Now, this task should take you a little while. Now remember, um, this is this is your summary of the topic. Now, I've chosen to do a mind map, which I will share with you, so you can use that to help you and to give you ideas and see what I'm sort of expecting of you to complete. So here is my mind map. As you can see, I've got the gas tests here, some little diagrams in pencil. Well done, Miss Pitt. Thank you. Um, I've got a description of pure substances, mixtures, formulations. Now remember, we can use chromatography to separate mixtures. Pure substances can be either compounds or elements. Now remember, with compounds, you can identify what ions are in an ionic compound by doing the flame test for positive ions, or you can do the negative ions test. I didn't have enough room to include the descriptions for the negative ions tests, but if you could include them, that would be brilliant. I've also included a little section here at the bottom about instrumental techniques, which can give us quantitative data. It can tell us um, how much of a ion is in a compound, as opposed to just telling us what ion is in a compound. So good luck with that task. I do look forward to seeing your creations. However you choose to format it, that's fine. So pause the lesson video, complete this task, and come back once you've done it. Now, guys, I do expect this to take you a little bit of time, so I know that I'll be on pause for a while. I don't mind waiting. Oh, hello. So you're back. Thank you very much for taking the time to complete that. You were gone a little while. So that leads us on to the consolidation phase, which I thought would be nice just to do a bit of a keyword Pictionary. We've played this before. So the pictures will sound out a keyword for this chemical analysis topic. What I would suggest you do is every time we move to a new slide, you pause the lesson, think of the keyword because you will need a little bit of thinking time, and pause it when you're ready for the answer. And the keyword for this being flame test. Next slide, please. Pause the video, think of the keyword, unpause it when you're ready. And the answer is lime water. Now remember, guys, lime water is the solution we use to test for carbon dioxide gas. It turns from clear to cloudy. And also we can use it to test for a carbonate as well. We'll come to that a little bit later. Next keyword, remember, pause the lesson video, think of the keyword, unpause it when you're ready for your answers. This one's a little bit difficult. Good luck. Now, the keyword is chromatogram. Chromatogram. Now, remember, guys, a chromatogram is the result that you get from carrying out chromatography. Now, remember, the chromatogram can tell us lots about the substance being tested. It can tell us how many different components are in it. For example, if there's 3 dots, we know it's got 3 different components. If it's 1 dot, we know it's a pure substance. There's only one thing in it. Next keyword, and the keyword is ding, compound. A compound being a substance made from more than one type of atom or element chemically joined together. So, 2 or more different types of atoms chemically bonded. For example, H2O, HCl, sodium chloride, water, methane, which is CH4. I could go on, but I'll stop there. Next keyword, pause it. And the keyword is squeaky pop. Now, remember, guys, the squeaky pot test is a test for hydrogen gas. Now, you get a little splint, you hold it in your sample of gas, and if it's hydrogen, you should get a squeaky pot test. And that is the positive test result for hydrogen gas. Hydrogen. Now, that's how I remember it's squeaky pot, because I like to say hydrogen in a high-pitched, squeaky voice. Next keyword, this one again can be a little bit difficult, so I'll give you a clue. The clue is think about group 7. Think about group 7. And the answer is halide. Now remember, guys, halide ions are formed from group 7 elements. So for example, chlorine becomes a chloride ion, so they're in group 7. When chlorine gains an electron to form a full outer shell, it becomes a ion, a negative ion, and we call those ions halide ions. Bromine becomes bromide, iodine becomes iodide. And remember, we use silver nitrate to test for halide ions. And chlorine gives a white precipitate, bromine will give a cream precipitate, and iodine gives a yellow precipitate. And the final keyword, pause the lesson video, have a think, unpause it when you think you might know or when you just can't get it. And the answer is shitting, carbonate. Now, guys, remember a carbonate is a negative ion, CO3 -2. Now, we can test for a carbonate ion by adding acid to our sample that we're testing. If we see it effervescing, if we see it bubbling and fizzing, we know it's producing a gas. We can bubble that gas through lime water, and if it goes cloudy, we know it's produced carbon dioxide gas, which carbonates produce, therefore showing the presence of a carbonate ion. So testing for a carbonate ion, add acid, bubble the gas through lime water, and it should turn cloudy. Now, guys, make sure you're completing the final RAG rating for the whole of this topic. There's a section for you to do that at the end of your student document. Remember to upload your work for today. I do look forward to seeing your summaries of this topic. And I look forward to being back in the classroom as of next week with face-to-face teaching. Thank you guys for taking the time to complete this home learning throughout the weeks that we have been in lockdown. It has been very much appreciated, and some of the standards of work and the answers provided have been absolutely outstanding. So thank you very much, and I look forward to us getting back to school and in the classroom.